Okay, stats. Let's finish up 9.2, which is the end of chapter 9, which is the last thing on the third test, by doing an actual problem. Let's go back to the brains problem. Listed below are brain volumes of subjects used in a study. Assuming a normal distribution, find a 95% confidence interval for the mean brain volume of the population. So we have the same 10 brains as before. N is 10. If we have 10 brains, you have one less than that for your degrees of freedom. So we have 9 degrees of freedom. What does that mean? Well, we know from the sample mean that we calculated earlier by adding them all together and dividing by 10, our x bar is 1130.2. Sample standard deviation. So we did this way back in chapter 3, but we learned how to do it in your calculator. So as a reminder, I would go back and check if you don't know how. Your sample standard deviation S should be 117.45. Now, you can do this by hand as well. I don't recommend. So draw a picture of the level of confidence. We want a 95% confidence interval, which means we have 5% split on the outside, so 2.5% on either side. So for this critical value, that means 0.975 is to the left and 0.025 is to the right. Remember, for the t-table, you want what's to the right. So we're looking at 0.025 across the top with our 9 degrees of freedom on the left, and we see that this is 2.262. So my margin of error is going to take my critical value times my sample standard deviation divided by n. So in this case, that's 2.262 times the 117.45 divided by the square root of 10, because my sample is size 10, and this is approximately 84.01. So again, once I have my margin for error, that gets added and subtracted to my sample mean, which is from above is 1130.2. So I need to take 1130.2 plus 84.01 to get the upper bound, and 1130.2 minus 84.01 to get the lower bound. So when I add 84.01, I get 1214.21. When I subtract it, I get 1046.19. So what does that make my interval? Makes it from 1046.19 to 1214.21. What kind of interval is it? It's a 95% confidence interval. So we can say we're 95% confidence the mean brain volume of the population is between 1046.19 and 1214.21 cubic centimeters. Now, one thing to note, the larger your sample size gets, the numbers on the t-table, again, are going to look like the z-table. So if you have like 1,000 samples, just look at the bottom of the t-table. It's exactly the same as the z-values for our critical values for confidence intervals. Okay, so just like we can do examples for samples, we should also go backwards and we should be able to figure out how many samples are needed to get a certain level of accuracy if we need it within a certain amount. So just like we had in 9.1, we can go backwards. Find the sample size needed to estimate the population mean with a given margin of error. Okay, the sample size required to estimate the population mean mu with a level of confidence, depending on the level of confidence, with a specified margin of error is given by n equals z alpha over 2 times s, where s is our standard deviation, divided by e squared, and you round up. Now, one thing you may notice is, wait a minute, I thought for samples we were using t-table. Why have we gone to the z-table now instead of t? Well, the t-table uses degrees of freedom. Degrees of freedom is derived specifically by sample size, and what we're trying to calculate here is sample size, so we don't actually have a sample size to use. So we have to use the z-table values. We have no other choice. Okay, you want to estimate the mean number of friends for all users on a social networking website. Assume S equals 50.2, sample standard deviation. How many users must be included in the sample if you want to be 95% confident the sample mean is within 10 users of the population mean? So we have N equals C alpha over 2 times S all divided by error squared. Okay, what's our critical value for a 95% confidence interval? Z-score, it's 1.96. Our S that's given to us is 50.2. Our error, you want to be within 10 users squared. Now, when you plug these all in, you get approximately 96.81. Now, what do you always have to do for N? Round up. That means you need 97 people. What that means is if you got 97 people's data, you would be able to construct a 95% confidence interval that gets you within 10 users of the actual mean number of friends users have on a social networking site. And this is all for chapter 9, because 9.2 is done. What this means is I will probably open the test Sunday around noon, leave it open until about probably Tuesday or Wednesday. You can take it whenever then. It'll be an unproctored test. This is your last test before the final. While we will be learning new things next week, they will only be on the final. There will not be a separate test for chapters 10 and 4. So we'll do more later.